So this is the second part of the chapter 4, D-Day number 4. This is the part that's no calculate. So on this one, we are going to be graphing an absolute value and a parabola. So for the absolute value, I'll do that one in green. And I'll do the other one, let's say in orange, okay? So for the first one, my vertex is going to be at -1, -2, and I have a stretch of 1/2, which really for an absolute value is like a slope. And then for my parabola, I have my vertex at 2, 3, and then that -2 is going to give me a stretch of a -2 that I'm going to be dealing with, okay? Okay, so for the first one, I'm going to start at -1, -2. I'm going to put my point here. And then, like I said, this 1/2, since it's a absolute value, which is linear in nature, it's like a slope. Every value is half as high, but I can look at this one up 1 over 2, up 1 over 2, up 1 over 2. Okay, let me do it the other direction. Up 1 over 2, up 1 over 2. And then I am going to connect this. And this one is a, whoops, I have it as a rectangle. Okay, sorry, as a line. I'm going to have this be a solid line because it has the equal included, okay? And I'll just adjust this one a little bit down, and I'll make it, okay. And for this, I would be shading less than, so I'd be shading below this, below. Okay, here, I'll just kind of, I'm going to get rid of this here in a minute, but I'm going to be shading below. And I'll just give a final answer that this would be my shading so far. For the next one, I'm going to go to 2, 3. And it is a parabola. And it has a -2 as a stretch. So what I'm going to think is I'm going to go out 1 from my vertex. 1 squared is 1. So I'd only go up 1 times by -2. I'm going to go down 2 on either side. I'm going to go out 2. 2 squared is 4. I'm going to times that by -2. I'm going to go down -8. 1, 2, 3, 4, 5, 6, 7, 8. And I'll do the same on the other side. Now this is a dashed curve. So I'll draw a dashed curve. And for this one, I would be shading greater than it. So I'd be shading above it. So I would be shading here. So what I want as my answer is where both of them are shaded, okay? And where both of them are shaded is here in this section and here. That's where I'm going to be shading, okay? So I'm just going to put the final answer here. So my final shading is going to be here, which is underneath this, but out greater than the parabola, and here. That's going to be my final answer. On number 2, we're going to graph this. So this is going to have an inflection point at 3, 2. So I'm going to go to 3, 2, 3, 2. This is a cubic graph. So from here, let me do the rest of it in orange maybe so that we can tell this is my inflection point in green. Okay, so if I go out 1 cubed is 1. Okay, if I went out 2 cubed would be 8, but that's going to go off my graph. If I go backwards 1, -1 cubed is a -1. If I go backwards 2, -2 cubed is a -8. 1, 2, 3, 4, 5, 6, 7, slightly off 8. And so this graph is going to look like that, okay? And my inflection point was that 3,2. On B, this one is a square root graph. It has an endpoint at -4, -3. So endpoint at -4, -3. So I'm going to start at -4, -3. And then when I graph this, I think about it's just square rooting. So I'm going to go out nice square roots. So if I go out 1, square root of 1 is 1. The next nice one is 4. So I'm going to go out 1, 2, 3, 4. And the square root of 4 is 2. And then the next nice one would be 9. So 4, 5, 6, 7, 8, 9. The square root of 9 is 1, 2, 3. And then I can connect it. Should be half of a sideways parabola. On letter C, this, if you want to think of a critical point, you can think, or locator point, I should say, -2, -4. That's not going to be a point on my graph, but it's going to kind of be a locator point for us. So my asymptote is going to be at y equal -4. So I'm going to go to -4. Let me draw in -4. That is going to be my asymptote. Here, I'll do the rest of it, maybe purple. So then if I go to this -2, -4, which basically is where my asymptote is, meeting with the with the y-axis, I go out 1, 2 backwards because that -2. This is where my graph's going to start. Here I go up 1 because that's like 2 to the 0. So I'm 1 above, then because my multiplier is 2, I double that, 2 above, double that, 4 above, double that, 5, 6, 7, 8 above. So this is really 2 to the 0, 2 to the first, 2 to the second, 2 to the third, but really I'm just timesing by 2. And then here is my exponential graph. On D, this is a reciprocal function. And if you want to think about a locator point, 1 for my x, -2 for my y, but that's going to be kind of where my two asymptotes meet. So I have a horizontal asymptote at y equal -2. My vertical one is what makes my denominator 0, which is x equal 1. So I'm going to have an asymptote at x equal 1. And I'm going to have an asymptote at y equal -2. And right here, you see that would have been my my 1, -2, which is kind of my locator point. That's like my new origin. Okay. Now, for the ones that we've been seeing, all of our top numbers are 1. So really, if I was trying to plot things, I go out things that multiply to 1, 1 comma over 1 up 1, over 2 up a half, over 3 up a third, and so forth. But the two main points that I want from you guys are the following. So if I went out 1 from this new kind of origin, if I went out 1 times 1. If I went out -1 times -1 would get me a 1. Those are the points that I want. Then we can just draw your reciprocal function. And that is that. So hopefully this helps you.